Okay, so Meta has added some new models to the Llama herd of models. And if we go back to when the original Llama 3 was released, a lot of people at that stage were actually expecting that the Llama 3 models were going to be multimodal. That's what quite a few rumors had talked about. And it made sense that a lot of other models, even some open source models, were going for the multimodal approach. But unfortunately, back then, we didn't get the multimodal models. Today, we have been given the multimodal models. So Llama 3.2 adds 4 new models, and it really seems to be a strategic release where they're covering what they didn't have in the herd already. We've got 2 multimodal models, which are basically just VLMs, so vision language models. And we've got 2 very small Llama models that are built for on-device stuff. So let's jump in and have a look at what they actually announced. So we can see that they've got the 4 models, starting out with the new Vision LMs, and they're calling the small one of these the 11 billion model and a medium-sized 90 billion model, which is a really interesting size that we haven't seen for open source models in the past. And then they've also released these 2 lightweight text-only models. So this is a 1 billion and a 3 billion model. And the whole idea around these ones is that they are basically made to fit on phones, on mobile devices, on a Raspberry Pi, etc. in there. So all of the models basically have instruction-tuned versions coming with them. The text-only models go out to 128K, and they talk about these being state-of-the-art for their class for on-device use cases. I'll look at some of the stats later on about the models and comment a little bit about where the models are strong and perhaps where Meta hasn't been totally transparent with what they've declared and compared against in their evaluations out here. But it certainly is nice to have these 1 billion and 3 billion models. I'll show you later on. You can already run these in Ollama. They're very quick and snappy, and it makes a lot of sense that these would be things that you would want on a mobile device. So we know that the new models that are coming with Apple Intelligence are around about the 3 billion range. We know that Google has the Gemini Nano models, which are in a similar size to this. We know that companies like Gwen have put out some models that are this size and some actually even smaller. But basically, we know that this is the right sort of size model at the moment for a mobile phone, that while you can run the 7-8 billion models on devices, you need quite a bit of RAM, and they just don't tend to run that quick. You can certainly imagine having one of these fast models with 128 token window, being able to summarize conversations in chat, read emails for you, do a whole bunch of small but very useful things that you could want on a mobile phone. It's also interesting that they've optimized these for certain kinds of hardware. On the other end of what Meta has released are the vision models. So these are definitely a lot bigger. We've got an 11 billion model, a 90 billion model. Like I mentioned before, the 90 billion is a strange size. We haven't seen that. Normally, vision encoders are not hugely big. So I'm not sure if this is basically a bigger LLM with Envision Coder or a much bigger vision encoder compared to what other people are using out there. But they talk about that these are basically drop-in replacements for corresponding text model equivalents. And you certainly can imagine that these are going to become very popular for doing fine tunes and stuff like that, just like all the Llama models. So if we look at the model evaluation, starting with these vision models, we can see that they're claiming that, okay, the 90 billion here is performing better than the GPT-4o Mini, and that even the 11 billion is performing better than Claude 3 Haiku. Remember that Haiku is the smallest model from Anthropic, certainly not the one that probably people would be using for doing really any sort of high-end vision stuff. Now, one of the things that I feel they're not being totally transparent here is that they haven't compared or benchmarked against the Gwen 2 VL model, the 72 billion version of that. If we come and look at that, they're actually benchmarking against Claude 3.5 Sonnet for their vision capabilities, and GPT-4o, not 4o Mini in here. So if we look at this MMMU, they're getting 64.5, which is quite a lot more than any of these models are getting. And if you compare some of the other stats too, you can see that they're also performing really well with a smaller model, right? Just a 70 billion model as opposed to a 90 billion model in here. Now, that said, the Gwen 2 VL model hasn't been out a huge amount of time. So perhaps in some ways they scooped Meta's announcement a little bit here. As with all LLMs these days, though, you really want to try out each of the models and see for your particular use case how it's going to perform. You may find that for your use case, the Llama 3.2 is going to be better for your use case. Following up on the vision benchmarks, we've got the benchmarks for the lightweight 1B and 3B models, and these certainly look impressive. They're comparing it to Gemma 2, which in some ways, surprisingly, has become a very popular model. Last month, I was in Beijing and talking to developers there. I was surprised how many of them were using the Gemma 2 2B models for mobile and stuff like that, even only been out a couple of weeks at that time. And they were using it for a variety of different use cases where they were basically fine-tuning it for things like chat, summarization, a whole bunch of different things like that. So that's going to be very interesting to look at. Now, the other model that they compare to in here is the Phi 3.5 Mini, which is one of my favorite models at this point. And I've got to say that, start off, the models are actually quite a bit smaller than the Phi 3.5. When you're looking at a 3B versus a 3.8 billion model, the other thing here is that it's strange that the Phi 3.5 does really well with GSM 8K, and the Llama 3.2 is not even close there. Yet, for the math data set, which you would consider to be harder than GSM 8K, they're beating the Phi 3.5 Mini. Again, this is where I find the whole issue around benchmarks more and more frustrating day by day as we go through this. And I really feel like at the end of the day, you have to trust a few providers that are putting out these models, try them out for your particular use case, and then see how they go there. So one of the things that really is interesting around the lightweight models is actually how they've created these. So these are sort of culled down versions of the Llama 3.18b, in that what they've done is they've basically pruned the model, and then they've done knowledge distillation from the 8b and the 70b models. So this is something that's really interesting, the whole concept of making these models smaller or smaller versions of these models where they're not training from scratch. They're basically taking the pre-trained versions, pruning them out, so removing a lot of stuff from them, and then fixing them up with knowledge, pruning them out where they're removing a lot of weights and probably even some layers from them. Obviously, they're working out which are the best ones to remove and stuff like that. Then they're doing the actual knowledge distillation where they're taking these Llama 3.1, 8B, and 70B and taking the logits layer out of those. So rather than just doing distillation where you're predicting on what was the best sequence, you're actually here looking at trying to predict the exact same probabilities across the softmax layer as you go through this. So this has always been a very nice way to do this kind of going from a big model to a small model. It's something that works very well. Once they've done this, they then go to a sort of more traditional post-training where they're basically doing fine-tuning, rejection sampling, and DPO for alignment in there. And if we go back to the Llama 3.1 paper, we can see exactly how they're doing this because it's the same sort of thing as what they did on the Llama 3.1 fine-tunes for the instruction tunes, etc. So along with the models themselves, Meta has also released some nice demos that we can see here for doing things like summarization, rewriting, etc. And another interesting thing, which probably deserves its own video by itself later on as I start to play with this a lot more, is that they've released these sort of Llama stack APIs. And clearly they can see that the future is going to be agentic apps. You can see this, what they're talking about here. And they're setting up to basically have a stack of where you can run all of these things together, whether that's going to be on device for a phone or whether that's going to be in the cloud. And I think this could end up being one of the really interesting things that comes out of this release as we start to play with some of these things and see how they're thinking about using these. Because don't forget, behind Meta, we've got the whole juggernaut that is Facebook that wants to run these models in their apps and do the whole sort of Meta AI thing. So the models are out. You can basically come in here to Hugging Face, and if you opt in, you will be able to get access. So they're gated access, stuff like that. But once you've opted in, you can try the models out, and you can see that, again, we've got a whole bunch of interesting things that are coming with these models, with the Llama Guard, as well as the traditional instruct and base models in here. I think you're going to see these models pop up in a whole bunch of places over the next week or so. Let's jump in and have a look at using this in Ollama and just see what speeds we get with these smaller text models. Okay, so if we jump into Ollama here, I've basically pulled down the 3 billion text model and the 1 billion text model. If we run the 3 billion text model, I'm not running it on a super fast machine here. This is a Mac Mini. You're going to see that it is actually pretty snappy in how it's writing the text and stuff like that. And also, if we set it to verbose, we can then actually come and see the tokens per second that it's actually generating out here. And you can see that we're getting 47 tokens per second on this particular generation. Earlier on, I was getting often 55 tokens per second out, which is very fast, right? When you're thinking that most people read at only a few hundred words per minute. And here we're able to generate out 50 plus tokens per second. That's certainly good. But really, of course, the main reason we want this is not necessarily for people to read it really fast, but for agents to be able to use this. Okay, trying the same thing with the 1 billion model, you can see that this is really flying here. And while obviously the quality is going to go down for this, it's probably not the kind of model I would use for doing writing tasks and stuff like that. This is definitely a nice, snappy model. We're getting around 80 plus tokens per second there. This is certainly a model that you could use for a bunch of little different things of doing some summarization, doing some simple extraction, that kind of thing. I haven't checked to see how well these things handle JSON and stuff like that yet. I'm not expecting that you'd really want to use this for doing function calling too much, unless you're going to be fine-tuning for specific tools, that kind of thing. The cool thing, though, is when this model is so small, fine-tuning it just becomes so easy as well. So perhaps that's something that we can look at in a future video, is fine-tuning these for some simple tasks and stuff. Anyway, just to finish up, this is definitely an interesting release from Meta. The models are all up. You can go and play with them. You can try these things out yourself. I do think we're going to see these models pop up on people's phones pretty quickly, and certainly people will be fine-tuning them for various kind of uses like chatbots and things like that. And then we've got the multimodal models, which Meta, has been really good at a lot of vision models in the past, things like the SAM2 model, etc. I made a video on. In many ways, this is the Llama team's first sort of dip into doing these multimodal models. And perhaps we will see even more modalities come out over the next few months. After having recently done a video about Moshi and stuff like that, you could imagine some really nice combinations of putting an audio model and training an adapter for that to go into a Llama model, which would be really cool as well. Anyway, as always, if you've got any questions or comments, please put them in the comments below. If you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.